Now we move on to the fifth presentation. The topic is value added sustainable production opportunity out of rice straws to economically uplift rice farming communities in Sri Lanka. The authored by Suriyarachchi DP and co-authored by Ranasinghe W, MND, Disanayaka MK and Nugawela CT. Dhanushi, it's your time. Thank you.
Today, my presentation is based on my final year comprehensive design project. Our research topic is a value-added sustainable production opportunity out of rice straw to economically uplift rice farming communities. My co-authors are Ms. Melanie Disanayaka, Ms. Dilshani Ranasinghe, and Ms. Chaturika Nugawela. And before going to the presentation, let's watch this video. Basically, our project approach was to come up with a sustainable rice straw management solution for the farmers while improving their livelihoods. Our concept was to come up with a value addition to the generating rice straw while enhancing the secondary income level of farmers during their non-cultivation period. This was an experimental project and comprised with the material development phase along with the product design phase. So first, we have started with simple domestic testings to get a better understanding on the raw material characteristics. And this is the first set of experiment samples with soil conditions to check the degradation period of the raw material. The second set of raw material set were conducted testing with different liquid samples, including acids and bases. With the experiment sets, we were able to identify that with different liquid mediums, the degradation period of rice straw material changes, and the degradation period is very low, even in a low pH level. This shows the material developed plan for composite sample making. It comprised with 3 experimental phases, including normal rice straw based pulp with additive samples, boiled rice straw based pulp with additive samples, and powdered rice straw based pulp with additive samples. The main reason for selecting these specific additives were considering the easy availability within the community surrounding, and as we are suggesting this production to do within the community, at the same time, consider the available rice raw material quantities and also additive quantities mainly, and considering the ability to mixing up with raw material and possibility towards developing material composite samples. In this slides, as showed, this is the material developed processed. As I previously stated, each and every phase has its unique way of developing the material piece. Basically, first we have to remove the water-soluble particles, and to improve the strength, we have to undergo on with pre-treatments for the raw material. Once all the done, can mix up with prepared additives and can make the composite sample pieces. This shows the first experimental sample set for normal rice straw based pulp with additive samples, and this is the dried out sample set. And here I have came up with a simple domestic testings to understand the material strength, and have given equal force with unequal pressure to understand the strength of the composite sample piece. And with the findings, we have included them into scale, as you can see here, and based on the GAIN simple domestic testings. So this is the second set of boiled rice straw based pulp with additive samples and the dried out sample pieces. And this is the last set of experimental pieces, which is based on powdered rice straw based pulp with additive samples. And this is how it looks like once dry out. As a summary, we were able to identify that BP1 sample, which is boiled rice straw based pulp with additive sample 1, holds the most strength comparative to other composite samples. With that, we have started with testing the developed composite material piece based on the simple domestic testings to identify the GAIN characteristics. The domestic tested criteria were testing with water, keeping underground, keeping on ground, heated with blue flame and heated with. The objective of conducting these experiments were to identify the stability of the developed material piece with different environmental conditions, and also checking the material performances without conducting prior standard lab testings. So these are the lab testings which we have undergone with the developed composite samples and the developed, and this is the density calculation. So as a summary of all these domestic and standard lab testings, we were able to identify the characteristics of the developed material composites, as you can see here. So considering the GAIN material properties, we were able to identify the possible applications of these developed material pieces. So as a samples, as you can see here, so as we are introducing, this is to produce within the community, so we have considered on the availability of resources to produce the material, and also considered on the hands-on skills of the workers, available techniques for the production, and also the manufacturing feasibility within the community. And at the same time, we have looked into the market demand and the need for the possible applications and what suits for the best. Considering all these factors, we have selected to go with green building material applications to further process with. So as the user segmentation, we have selected suburban area compact space office interiors who are following up sustainable strategies. So during our findings of the users analysis, as requirements, we've identified that the workers are highly stressed out with the working space, and they're highly lack with fresh air, and the positive working environment is lacking. So with that, we thought of introducing the biophilic concept, which helps to improve productivity and air quality that brings the exterior nature into the interior space. Here are some of precedent studies of biophilic design concept applications into interior in global context. So this is the second phase of the project, which is the product design stage. So first started with the stable geometric forms, then improve the outer surface further by introducing cut shapes and different body forms while maintaining stability. Then introduce the unit-to-unit connection, building interlockings into the form. Then further come up with an additional stability by introducing both vertical and horizontal interlockings to the form. As the incorporation of biophilic concept of pottery area was introduced to the form at the same time by considering the interlockings and the stability. And as the next stage, consider the manufacturing feasibility of the modular unit, and enhances at the same time by enhancing the interlocking. So as the final design, this is the introduced modular unit, which provides the stable geometric forms with horizontal and vertical interlocking while providing a potting area. So the modular unit has further developed, introducing plant potting, potting area with mid-plane potting, vertical potting, and horizontal plane potting. So this is the basic modular unit, and this is the vertical potting unit, the mid-plane potting unit, and the horizontal plane potting unit. As you can see here, the outer layer of the modular unit, it comprised with the developed material layer, and the inner layer is a fertilizer layer, was again developed along with the design. So, and these are the inner fertilizer layer development experiments. So while developing the fertilizer layer, mainly we have considered on the interior planting ability, then nitrogen, potassium, and phosphorus nutrition values, fibrous structures, medium, and the degradation level, the moisture level, and the water absorption level, and also mainly the nutrition value, releasing speed, and the capacity of the fertilizer. So these are some of the plant suggestions for the modular unit setup, considering the low root growth, less water requirement, and the fibrous soil texture medium requirement for the plant growth. So when it comes to the product design mold, the mainly here we have considered about the hand ergonomics, the geometry, the pad geometry, ejection forces, and mainly the draft angle while designing the mold, while releasing the mold also without damaging the production. So that's the main reason why we have mainly considered about the draft angle of the mold. So this is the manufacturing process of the material development into the final outcome. So, and this is how it looks like with the final prototype design, and with the, once it becomes a modular setup. So the stacking of the modular unit can be changed with incorporating different potting variations with unique modular units by incorporating them. So this is how the stability works, and this is the stability calculation of the setup. And this diagram shows the production planning to distribution of how the production flow happens, how the information flow happens, and the cash flow happens from community to market and back to community. So we are marketing this to the interior designers because they are the ones who are very familiar with these sort of green applications, green building materials. So we are marketing this to interior designers. So here are some logo design tryouts and how the packaging, storage, and transportation happens. So this is how the biophilic setup with the interior works. So this is how it looks like with the once it installed within the interior. So we have separately providing a maintenance user guide for user, and also an installation guide for the client, which is for the interior designers. So this is the cost calculation for the unit, and as a project objective, we are providing additional income around 20,000 per family per month to improve their income level during non-cultivation period. So at the end of the project, we would be able to increase the sustainable rice straw management. We would be able to provide a sustainable rice straw management solution for 735 acres farming families, And also we would be able to save nutrition value of nitrogen, phosphorus and potassium, which is including in the rice straw. And also we would be able to minimize the rice straw burning and its impact of greenhouse gas emission. And also not only that, as a long-term goal of the project, we would be able to increase their income level, and also we would be able to uplift 126 rural farmers. So as a long-term goal of the project, these are the sustainable development goals which we would be able to reach through the project. So for further developments, we can be develop the material further by expanding the applications into exterior as well. And also we would be able to further explore on the different stacking methods by incorporating different organic forms. And yes, when it comes to the limitations were like mainly with the material applications with the gained properties, it is not applicable for exterior. So with that, and also with the available techniques, with the available skills of the workers, the available resources, we had to stick to this sort of final outcome. So, and also the production was limited based on the available rice straw and the resources. So that's the final outcome. And so this is the system design which we were proposed to the community as a final outcome of the project. So that's all about the presentation, and thank you very much for listening.